last of our 9 technical experiments which we developed is the PV battery ratio experiment. So here we do have a small house, and there are 4 PV panels on the rooftop and 4 batteries stored in the basement of the house, which you can't see in the moment. And here we can find out what is the optimal ratio between PV panels on the rooftop and battery storage in the basement. Because if you do have a lot of PV panels on your roof, but only one battery, these PV panels will charge the battery throughout the day, and during the night, if you want to switch on the light, the fridge should function. It doesn't last over the night because the battery capacity was not big enough. Otherwise, if you have the basement full of batteries but only one PV panel on the top of the roof, this PV panel is not enough during the day to charge all these batteries in your basement. So if the night comes, the power does not last you throughout the night. Why? Because all the batteries haven't been charged throughout the day. They couldn't have been charged because of the missing photovoltaic panels on your roof. So how does this experiment work? Here on the back again, we do have a description card for the experiment, and there we see there's already again an IP address given and a password. So this microcontroller, the ESP32 here, puts up his own Wi-Fi network, and now we can log into this Wi-Fi network. So let's go to our mobile device, either our cell phone or a tablet, and there you connect to the Wi-Fi of this experiment. Now don't be disturbed if your mobile device says no internet connection, because yes, we don't have internet connection and we don't need internet connection because the website we want to visit is stored on this microcontroller. So as long as we are connected to the Wi-Fi of this experiment, we'll be able to open that website. To reach the website of this experiment, you need to know the IP address which is given on the information card, and that IP address you type into the top bar of your Internet Explorer. And if you type it in there instead of www. something, you type in the IP address and then you reach the website through the network where you're connected to from the experiment, and the data, the website stored on that experiment, on that microcontroller will be shown to you on your web browser. So now here I'm already logged into the web browser, and you can see we have a couple of things we can change here. So on the first site, we've got 1, 2, 3, 4 different sites on the website. We can switch on and off solar panels. So if I type here, I can switch on panel 1, panel 2, 3, and all 4 panels. And on the battery part of the website, I can switch on the batteries stored in the basement of the house, 1, 2, 3, 4. And lastly, here's some load, which I can switch on and off, or it can be done automatically, which I can set in the settings. So I do have a light, a fridge, an air conditioner, a dryer, a dishwasher, and a TV. So during the day and during the night, I always have some electronic components which are running and which are sucking the energy which is produced by the PV panels. So even over the day, not the whole energy coming from the PV panels can be pushed into the batteries, because some is directly used. That what we have above what we're using can be stored in the batteries, and that we can then use overnight. So on the last page, we have some settings which we can do. For example, if we don't have an artificial sun like I do have here, which helps with this very small PV panels, because the normal daylight or the light from the light bulbs in the room is often not enough. If you go into direct sunlight, yes, that would be perfect. That is even better than this artificial sun. So if you do not have artificial sun, you can also use this toggle to switch on the simulated sun, and then you don't need the real sun. That's what I'm doing for now for demonstration purposes. So now I'm going back to the modules, and let us start with maybe 2 panels. So I switch 2 panels off. With the battery, maybe I also take 2 batteries in the basement, and then I press the start button. So now the simulation, which is kind of a mixed simulation because it is running on the hardware here, and you can also see on the small display here, you can see what's happening. So it is a hardware-based simulation, so to say. It's not only software, it's running there on the hardware, but you can monitor it and set the settings here from your mobile device. So now I do start the measurements. And as you can see here, we've got now 2 cells, and we can see the state of charge, though the 2 cells are charged. But if I switch to the modules, for example, I see here that it is measured what the modules produce in energy. So here we have a peak at 12 p.m. The sun is shining very hot. So here's the peak, and then comes the night. So 6 p.m. is already dark outside. No energy produced. And now we can have a look at our battery, and we see, oh, the battery didn't last. It lasts only till 6 p.m., but we wanted to have energy throughout the whole night, which we couldn't have. So maybe we must change some settings. Let's go to the maximum. We take 4 battery packs and 4 PV panels, and we restart the measurement. So here you can see again the power produced by the PV panels, and on the other hand, the charging state of the battery. And now the interesting part is, will they last overnight? Will it make it without reaching the 0 line? Yes, it did. So at the end of the night at 6 a.m. when the sun is already rising again, so the PV panels will produce new energy with the new day, we still have some capacity left in our batteries stored in the basement, and that's what we want to achieve. We want to have energy throughout the whole night. And your learners now should optimize this, because the maximum is not always the top solution, because it costs a lot of money. So actually you want to find the best solution with paying less money. So to optimize, we said that a PV panel costs around 10,000 South African rand, 500 euros, and a battery costs 1,500 euros, around 30,000 South African rand. So that your learners can make up a table, say 1 PV panel, 1 battery, 2, 2, 3, 3, 4, 4, so that you have a matrix and you can put in there till what time lasted your energy stored in the batteries and how much did it cost, because the maximum 100 PV panels on the roof, 1,000 batteries in the basement, yes, it works, but it's not sufficient. You have more than you need and you pay more, and you could have the same result for less money. So for learning objectives with this experiment, you could also add on to go towards smart home, because here we have already a monitor system for your home which you can have a look at through your mobile device, and we could add on and program this maybe with a small camera inside, maybe with a sensor if the door is open or not, or a mechanism, for example, to open and close the door while sitting on the couch, something like that. All the material used in this small setup, the STL files for the 3D printed parts of this small house, which PV panels we use, which components, the circuit diagram and everything else, you will find down below in the description of the video. There we'll have a link to our website of the University of Stuttgart, and there we'll provide all the data which you need to rebuild this small setup. The costs for this small setup were around about 50 euros, which is 1,000 South African rand. And the most expensive part besides the microcontroller is the power bank, which sits here inside the house. Maybe I get it out, but it really sits nicely in there. So if you say you want to save some money, you could use this one from other experiments from your private power bank, or you could plug this directly into a power supply for the normal plug where you charge your cell phone or something. So you don't necessarily need this power bank. Yeah, so this material will be free of charge. You can use it, you can adapt it. So with this experiment, you have the opportunity to upskill your learners towards renewable energy. So later on, if a customer comes and says, well, my batteries don't last over the night, but I bought 10 extra ones, they have an answer because they experience this in class, in your lesson, and they grasp the concept of how this thing works and what to be aware of. Yeah, so this was the last of our, for now, 9 technical experiments we developed. Maybe in future there will be some more, but for now, have fun with those we developed with the material provided. And we would be very glad one day to see maybe on your YouTube channel how you use these experiments, what you've done out of it, and that would be very great. So please feel free to use this content for your own educational context.